This is Chapter 3, Section 1, and we're going to talk about scalars and vectors today. And like I said, I've asked you to bring in your protractors because we're going to work with our protractors too in drawing vectors ourselves. So the two terms scalar refers to anything that has magnitude only and it doesn't refer to direction. So if we ask for speed as compared to velocity, speed scalar. Velocity is a vector because velocity would show you direction. So if you said you're going 45 miles per hour, that is speed. But if you said I'm going 45 miles per hour north, then that also shows direction, and that would be velocity. So you can see the difference there between a scalar and a vector. And for our next quizzes and tests, make sure you know the difference between the two. Mostly we are going to deal with vectors and you trying to show direction. That's what we're going to do today with our protractors also, is show direction. So when you give answers, make sure direction is included in that.
The values used to express physical quantities can often be classified as one of two types based on whether or not their description includes a direction. Quantities that consist only of an amount or magnitude are referred to as scalar quantities, or scalars. Examples include the number of pages in a book or the volume of a container. Quantities that must include a direction in addition to a magnitude are referred to as vector quantities, or vectors. Examples of vector quantities include force and displacement. Often, vector quantities are represented with an arrow. The length of the arrow represents the magnitude of the vector quantity. The direction of the arrow represents the direction of the vector quantity.
Going back talking about the video, the two main things you were supposed to get out of that is whenever you're drawing these arrows, which is what you're going to be doing on your homework today, the arrows, the length of it shows the magnitude. So the shorter the arrow, the smaller your value, depending on if you're talking about velocity or volume or whatever it is. For us, it's going to be things like velocity, distance, and acceleration. And then whatever direction your arrow is pointing, if it's pointing up or to the right, that's considered positive. If it's pointing down or to the left, that's considered negative. And then whenever you add in the 4-quadrant system, as far as compasses go, the north, south, east, and west, what's considered positive and negative. Right here, we're talking about first graphical addition of vectors, and they are showing you the new term that you're going to learn today is resultant. And that term will be basically used for the rest of anything we talk about dealing with mechanics for the rest of this trimester. So a resultant vector represents two or more vectors. And depending on the direction of those vectors, are you adding them, subtracting them, what are you doing with them? It's given an example. It shows you a friend's house, the school, and then the student's displacement there as it walks from their own house, and the dotted line is what's considered the resultant. So from your initial point to your final point, even though you may have taken some type of crazy path to get to that point, the resultant is typically going to be the main part of what we're looking at. So even if this is one point and this is the last point that you go to, you may stop in several places along the way, but the resultant is going to be that dotted line from your initial to your final point. And to do this, we are going to look at something called tip-to-tail method. This triangle method of addition. Vectors, something that you can do with them, they can be moved parallel to each other. You can draw one vector with its tail starting at the tip of the other as long as the size and direction of each vector do not change. So again, that is called tip-to-tail method. And then your resultant can be drawn from the tail of the first vector to the tip of the last vector. So before I draw you one myself, there is a video that we're going to watch on this, so pay close attention to what they're calling a tip and what they're calling a tail.
Added graphically by drawing or positioning the vectors one at a time with the tail of each new vector connected to the tip of the preceding vector. Note that in order to add vectors, they must have the same units and describe similar quantities. The result of adding two vectors is called the resultant. The resultant vector extends from the tail of the first vector to the tip of the final vector. The order the vectors are added in makes no difference. Let's start with the same set of vectors again and put them together in a different order. You get the same resultant if you add the vectors in any sequence.
I do want to say one other thing which you might not have caught, especially if you're watching this for the first time. But as you're looking at this, when they called, again, I'll draw a dot here, and then there's my arrow. So the dot is the tail, and the tip of the arrow is the tip. Okay? Tip to tail method. So if I have a second one, draw it. Notice that I did not draw from my original dot. You can't have the start of two vectors start off the same location. You can't have the start of two vectors starting from the same location. So I cannot take, don't want to do that. I cannot take that dot and then draw another vector here. That's not going to be right. So if I take another one, again, my arrow right here. So start at the tip of the arrow and move out. Now, my resultant, though, you're going to start from your original point that you had and go to the wherever the tip of your final point is. That is your resultant.
It says if the size and direction changes, so the direction can change by itself or the size can change by itself, but it can't change.
It's going to depend on, you're going to be given word problems. You're going to be given things like an airplane travels 40 kilometers per hour, 10 degrees north. And then it changes and says it's traveling 150 kilometers per hour, 70 degrees west. You're going to be given a lot of information, and you're going to draw vectors to represent the speed, and then you're going to point those vectors in a direction to show, well, what direction is it actually going? And we're going to teach you how to do all of that.
I was just confused because in the PowerPoint it says you can draw.
So, some properties of vectors. It says they can be added in any order. That's what it showed on the video. To subtract a vector, you add its opposite. So, if a vector is given to you as 40 kilometers per hour going east, to subtract it, you would, what's the opposite of east?
West.
You would draw it going west. Okay? So, that is key whenever you're subtracting. It is the opposite. So keep that in mind. And multiplying or dividing vectors by scalars results in vectors, and we are going to show you an example of how you can multiply vectors.
Parallel to themselves in a diagram. Regardless of their location, they have the same direction and magnitude. Vectors can be added in any order. Regardless of the order in which vectors are added, the result is the same.
So again, your resultant, which is you're trying to connect your initial starting position to your final ending position. Okay? So the tail of it starts at your initial, the tip of it ends wherever you finished.
It is also possible to subtract them. We remember that subtracting a number is the same as adding its opposite. For example, 10 minus 5 is the same as 10 plus negative 5. The same holds true with vectors. To subtract the vector d2 from the vector d1, we simply add a negative d2 to our original d1. The negative of a vector is defined as a vector with the same magnitude as the original vector, but opposite in direction.
So everybody caught that. So if it tells you to subtract two vectors, you take whichever one's supposed to be subtracted. Technically it's adding, but you're adding on that vector in the opposite direction. Same magnitude, but opposite direction.
By a scalar results in a vector. Multiplying this vector by 2 results in a vector that is twice as large, pointing in the same direction. Taking the original vector times negative 3 gives a vector that is even larger and points in the opposite direction.
So now we're adding
Okay, this is the problem. We're going to work this one out on the whiteboard first. I'll take a picture of it once we're done. But I want to make sure you get the feel for I have a large protractor, how you should use your protractor. There's several pointers I'm going to give along the way.
There's nothing wrong with it.
This thing works as a piece for it. Like a crosshair piece right there.
Yeah, that's like, so what you gotta do is he moves west. What is hell?
No, that thing it fell off was the thing you're supposed to use. Just draw a straight line. Yeah, everybody's you. That's how am I supposed to do? You draw one.
That's what I have.
I can't fix it. I think you lost another. There's another piece in your back. Look in your back. Fix it. If you got the other piece.
Yeah, you draw
Are you sure? You ever let it stay in there because you lost a piece?
Where's the other one? Look, it's